Okay. Hey there, strangers. It's time for another 2 p.m. PC Twitch stream. I'm your host, Strangebro Jim, and today we are going to be getting back into my development of my game, GGG, something that I do every Sunday. Um, now, last week we were tackling quite a bit of trying to arrange the map to allow for the saving of the paths. Now, if you've been kind of following me on this week to week progress, you'll know that I wasn't feeling comfortable starting the D-Star process because um, I wanted to be able to save the paths afterwards. Okay, I wanted to be able to save um, these D-Star paths so that if they change or um, if there's like a new development for them or something along those lines, then um, then the paths can obviously be modified. Otherwise, um, they'll just be they'll just have um, the same paths stored so that the agents can reuse those paths over and over and over again. Um, when I was originally looking for any updates for the um, for pathing, and this was a couple weeks ago. Um, I wasn't sure if there was anything better than the A-star. Now, uh, I will let anyone know that um, um, that I do know about Unity's own pathing built-in. Okay, I do know about it. Okay. There were several points that I brought up that I was a little concerned about it because right now I'm just doing very, um, set placements. Okay, much along the lines of like chess, if you really want it to be that way. Okay. Um, I'm doing a tile-based game right now, and I'm afraid that Unity's A-star might be a little too complex for what I need at this time. Um, this is more, you know, I did the 2D roguelike for um, for a tutorial into Unity, um, because I'm looking at it and I don't have the necessary skills to do 3D art right at this point in time, so I'm trying just gonna try to stick with 2D for now so that I can get a rough understanding of what Unity is all about. Okay, that was the initial plan for that. Um, the so I basically was using the 2D roguelike as a stepping stone to this game that I'm making now. Okay. Um, so um, hold on a second. I need to make sure that my volume is working here properly. Otherwise, my headset will stop on me. My headset needs input coming in and not, it doesn't stay on for output going out. So I have to have some music in the background. But just to let you know, until something happens with like Twitch and the record companies or YouTube and the record companies, I can't play any music. So I can always try to go for copyright, but I've gotten hit by, or non-copyrighted music, but I've gotten hit by copyright strikes from record companies anyway afterwards. So it's like, okay, well, apparently I can't really win. There might be some artists out there that are willing to um, that might be willing to let me play their music. I think I've had like one person saying that I could use their music, um, but I mean at the same time I do kind of need a little bit of variety as well. So, but whatever. This is neither here nor there. Okay, back to the overview. Um, so I looked up um, if there was anything better than A star that's out there. I mean, it's been a while since I've done any kind of like major um, artificial intelligence studies or research or anything along those lines. So there might have been there might have been a recent algorithm out there that's better than A star. I don't know. Um, it's been several years. Someone probably could have thought of something, and someone did. There was definitely some new concepts that are out there. The two that I was looking up were D star and LPA star. Uh, Now, when I was looking at LPA, it had a similar concept as D star, but um, it tries to keep the um, it like tries to hold on to the information um, that you made the path for, um, which is good. It's very similar to what I'm kind of needing to do. Um, it's similar to the kind of idea that I was thinking about doing. So, um, seeing that all the units that are going to be on the map are going to be using pathfinding. Okay, the humans, the hunters, all the monsters that are out there. Um, the um, I was a little concerned in that um, the amount of processing that it would take to try to handle every single agent's pathing all the time was probably going to bog down my, um, going to probably bog down processing power, processing. I might be, I might be worried for nothing. Okay. Um, you know, um, maybe my computer can absolutely handle it and not have any issues. It's totally possible. Um, but um, the, uh, I still had that concern that as the units increase over time, as the map gets larger and larger, I'm looking at, potential of like, 50 units out there in the world, all doing their own specific tasks, and you could have two, three, four, five, who knows, all saying, "Hey, I need to develop my path," all at the same time. Now, it might be perfectly fine to handle that. It might be like, yeah, no problem, we can do this. Um, then again, it might not. So what I plan on doing is I plan on saving those paths. Um, so like, an agent gets to a specific node, goes, I need to get somewhere, and no path has been taken care of for that particular path to, another node. So D star occurs, finds that path, and that particular node saves that path to the other spot so that if anyone reaches that node again and wants to go to the same destination, I mean, it's going to happen, um, then, I want that node to be able to say, hey, I already have a path to that particular location. Here it is. No D star needed. No path searching required for something that has already been established. Um, Now, one of the positives of D star is that if there is a um, some kind of barrier or something that's in the way, then the agent can reroute. Okay, they can find a different path. Okay, based off of D star. Okay, but the um, but the node itself is what's kind of going to be kind of keeping those paths. Okay, so I needed code built into um, built into my game to try to handle that storage before I started getting into D-Star proper. If I got into D-Star too early, then I wouldn't be able to arrange for those paths to be um, um, stored in the node itself. So, I needed to kind of be a little careful along those lines. So, um, now um, there's going to be some amount of elements that I'm going to need to kind of do, um, that I'm going to have to like add a little bit later, um, concerning Fog of War. Now, obviously, Fog of War is something that uh, I'll let the player choose as to whether or not they want it active or not. Like whenever they start up a new game, I'm just basically going to give them the option. Do you want Fog of War active or not? Okay. If it's active, then it makes things a little bit more difficult for the player. Um, and some players might not want that. Um, so I need to be able to have the Fog of War be active or disabled depending on the situation, depending on the player input. Okay. Um, like I have uh, I follow an individual that's disabled and he still loves playing video games, but he's not able to use his arms. Um, so it makes it difficult for him to still enjoy playing video games and not have the right controls set to be able to do that. Um, and he loves games that are easy to play. Um, because it's still fun for him. Um, you know, I once asked him if he had like a list of developers out there that um, knew how to kind of work with setting up specific code to try to help him out. But I never got word back from him on that. So he might not be aware. He might not know. Or I might be too small for him to see my I, my request. But it's okay. Um, I mean, he's part of a larger organization and like so. I probably didn't even pop up on his radar, which is okay. Um, now, um, that still doesn't mean that I can't try to work my game to make things a little bit easier for him if he ever decides that he ever wants to play my game. Okay. Um, can I adjust my game for every single possibility? I don't know. We'll have to see about that when the time comes, when I start working on the controls. But for now, I'll do what I can to try to make things a little bit easier for um, um, I'll see what I can do to try to make things a little bit easier. But obviously, at some point in time, I do want to get that game released. uh, so I'll see what I can do about uh, handling that set amount of controls. But um, that's going to be later down the line in the project. Um, so right now I'm working on getting all of my errors cleared out first before I move on to getting D-Star, um, start working on the uh, pseudocode for D-Star and start implementing that into the pathing. So everything should be relatively good to go for the most part. Um, Here, 1 second. I do want to bring up one. Uh, I want to bring up one text document first before we get too far into this. Now, one thing that I want to mention, as I do with most of my beginning of my streams, I mentioned about the stream team that I created. There's an application link down below for it if you're interested. Check out the Google document that is contained in the forum. It talks all about the team, what it's all about, the concept, the mission statement of everybody helping out each other out. So look it over. It's a lengthy document, I'll admit, but it's meant to have a solid foundation so that we can build a decent team out of it. Um, so check that out. Apply for the team if you're interested, and you know, and I'll send you a response one way or another on it. So that's a promise. So, with that being said, we are pretty much good to go. Let me. Okay, I think I know where this text is located at. 1 second. Let me go ahead and grab it real quick. Let's see. Scripts. There we go. All right. It should give me what I need now. Yeah, there we go. That's weird. I don't need that open. Okay. Alright. Let's go ahead and get this live. Alright. Oh, wait. Wrong location there. Expand that out so that I can keep an eye on the files here. It would be helpful if I actually had it switched over to the right scene. Hold on a second there, folks. I'll be right back on this. I'm messing up. Professional streamer, right? Okay. There we go. Unfortunately, I had left on the scene from yesterday. Um, Alright. Apologies on that. We are back. Alright. So, as you can see, I have some errors that I need to take care of. So, we are going to go ahead and continue working on that and get that ironed out before we can move on to the D-star. So now let's continue going one by one down our list here. Typically you want to try to start with the top one and go on down because sometimes um, you know, later errors might be a combination of issues that you're having to kind of face again. So, okay. Okay, don't have those files open. Okay, I don't necessarily need humans, ghosts, goblins, ghouls, or warriors open at this point. So we are going to go ahead and open up hex path, hex tile key, and I believe that should be good. Yeah, we should be good there. Okay, so error is in the hex tile file. So we have Max Tiles, which is a member of the board manager here. So at least I believe it was. Yeah. So um, so now I need to know whether or not I can try to access Max Tiles from within hex tiles. Hmm. Let's see if maybe I can just do maybe something simple like that. Probably not. Hmm. Interesting. It doesn't have a problem with that. Hmm. Okay. Well, we'll move on. If it's not gonna have an issue with that, then we'll continue. Okay, so um, okay, so we're dealing with this error here. Okay, so path file, add tile. Let's see. Path to follow is a hex path. Okay, so it's looking for a tile key on that one. Okay, so um, well, we're probably going to be needed to do um, something here for that. So temp, we'll set that to null, and then we'll send temp in there for now, just so it's it doesn't have any issues along those lines. Okay. Um, 124. Can I convert from float to int? Okay. Next tile, generate hash key. Oh, these are floats, huh? Wait, I don't necessarily want them to be floats though. Hmm. But vector2 is floats. Hmm. I think I might need to have like a um, first off, let's see about just kind of casting these into ints, because technically they should only be the tile numbers, the values I'm listing under the hex tile key value. Um, so um, so it should be I should just be only needing the integer value on that. Um, but you know, destination should only be like containing that for now. It could be, well, we'll have to kind of wait and see on this, but um, that value should be integers. If it's not, then I'm going to need to kind of figure that out, which means I'm probably going to want to do something along the lines of getting the destination key here. So path in destination is, and then just so we can get a rough idea as to what the values are before we convert them into integers. So, okay, so we have object reference is required non-static. Okay, let's go ahead and recompile here real quick and see what's going on. Okay, so hmm, interesting. Okay, so we're having some issues with this line here and this line there. Object reference is required for the non-static. Hmm. Let's see. Don't know what's going on here. Add path. Hmm. Let's see, an object reference is required for the non-static field method or property. Hmm. Let's see. Hmm. Could we be having a problem with the hex tile here? Hmm. Okay, let's see. Okay, so we still need out there. Okay. We're gonna wanna, let's see, testing path. Cast those. still having some issues with this, so probably gonna need to figure out what the issue is with the object reference there. So, um, for the time being, I'm just gonna kind of skip it for now because it might be something simple or it might be something that I'm probably gonna need to deal with a little bit more. So, um, okay. Um, so okay, so we're looking at this and we're seeing the fact that they're warning me that there's been nothing set for the next tile node. Um, so okay, so both of these work in conjunction. Okay, so let's try to work this out here a little bit. Um, so we come here to the testing path. We have our destination that we want to go to, and we want to try to get the next tile node that we want to walk to. If I'm an agent, so um, you know, we check to see if the agent has a path that they're already following. Um, if they're already following it, then we just need to skip this. If there is no path that they're following right now, then we go inside. We get the hash key based off of the destination that they want to go to, and we check to see whether or not that particular node has a path already established. If it doesn't have a path that's already established, then path to follow will still be null. Okay, meaning that D-star has not been um, established for this particular node to that particular destination, which is going to take place a lot, at the very beginning of the game overall. Okay, so um, if path to follow is null, then it's going to skip this, and path established remains false. Now, what's unfortunate here is the fact that um, this is basically saying, hey, you need to reassign tile next node a value. And it's like, well, nothing's changing on it, so why would I assign something to it? But apparently that's not how it works. Um, so, um, so what I'm going to need to do is we're just going to do an else here. And we're just going to say next tile node is equal to the next tile node. we'll see if that has a problem with it. Um, you know, just in case, I'm gonna put a little note in here real quick. Um, there is no tile for the agent to walk to. So next tile node does not change. Let's see if there's yeah, apparently still doesn't really like that very much. Okay. Um, yeah, okay. Let me look this up because I don't I don't want it to change. I don't need the vector2 to change on me. So um, C sharp when the out value doesn't change. Let's see. Okay, well, this is definitely not what I'm looking for. Never mind. Um, let's see. Let's see. Okay. Let's see. Just trying to find a example here. I have a situation where I don't necessarily need to change the value, but so far I'm not finding anything right at the moment. Hmm. Um, let's see. I like the fact that this guy's like no no all the no, but this guy's basically saying, hey, I can't modify the CO class. So um, but again, this isn't exactly what I need. Um, um, hmm. What to do when the out value doesn't need to change? Okay, I made a call, but I don't actually care about the messages. If it was an input parameter I didn't care about, I just pass in a null. So return I didn't care about, I just leave it off. Is there a way to do something similar with an out, or do I need to declare a variable that I will then ignore? Similar question here. Alright. Starting with, it is possible to avoid the pre-declaring out parameters as well as ignoring them. Okay. Hmm. Let's see. Um, hmm. Fortunately, you're required to pass something because the method is required to set it, so you cannot send null because the method being required to set it would blow up. One approach to hide the ugliness would be to wrap the method in another method that does the out parameter for you, like so. Hmm. I mean, this is similar to what I'm kind of looking for, but not quite. See, I I don't need to have like a null value in, I don't need something, I just need the same value as before. Hmm. Maybe, maybe I need to switch things around a little bit. Maybe instead of a boolean being a return, maybe I should set it to being the vector2 being returned. Hmm. I mean, I'm gonna need, but I still need to kind of bring in the, let's see, hold on. No, no, it should be, should be able to switch things around here. And I'm gonna need to, um, I'm gonna have to, I can just kind of do something like this. And, hmm, let's see, let's go here real quick. So, hmm, let's see. Okay, if there is a path, then we're just getting we're just going to the next tile there, so hmm. Otherwise we're gonna establish our path and find the next tile there. So um, okay, let's rearrange things a little bit here. So what we're going to do is we're going to take this, we're going to go to our agent here, and we're going to move that here. Then we're going to take this, move that there. We're going to get rid of this here. This is a bowl. So, and we're going to have it front out. Um, then let's see. Um, let's see. This is going to change here, or it's not going to change, so we don't necessarily need to worry about that. So then we just return next tile node in that case, in that regard. So that should be fine there. Now we go back here and fix this. So first we need to move that there. Then we're going to need to take this, change that there. Okay. I think that should work. Let's see if the compiler agrees with me on that. Okay, so we're still dealing with that, which is understandable. Yeah, it had an issue with this, and was kind of surprised that didn't pop up again. Okay, we'll ignore it for now. Um, Concurrent dictionary does not contain a definition for remove. Okay, so let's move on to that issue. So we're looking at this. Okay, so concurrent dictionary does not have a remove function. So we're gonna have to figure out what it does have that I can use. Okay, so concurrent dictionary. What do you have for me? see, methods. Getter add. Attempts to remove and return the value that has a specific key from the current. Hmm. Let's see. Okay, so this has to have like the actual item itself that, is represented in, um, it basically contains both of them. And, um, I don't really care about both of them. I'm just trying to get the hash key to be removed out of that. Um, so this isn't exactly what I need. Attempts to remove and return the value that has the specific key from the concurrent dictionary. Key of the element to remove and return. When this method returns contains the object removed from the or the default value that exists. When the method returns contains the object removed from the dictionary or the default value of the true value type if the key does not exist. Yeah, this is a little bit more than what I'm kind of looking for, to be honest, but don't think there's anything else here that I can. I don't think there's anything here that I can work on here. This is going to be handy. Matter of fact, I should probably put that in. Publish void path at pathing dot clear. There we go. Because when the map is done when the level's done, we're gonna have to kind of clear the board to allow for everything to kind of be reestablished again. Um, so I'm probably gonna need to uh, like manually go through all the nodes and clear out all the paths that are there. So hmm. Let's see. Hmm. Explicit interface and limitations. Hmm. Interesting. Okay, well, it's looking like there's really nothing that I can really do about this. I'll have to do the try remove and um, but wait, I don't have the t value though. Hmm, okay. So if I was to basically say that the t value is null, then it shouldn't have a problem with it. So if I was to basically say try remove hash key and null, then it shouldn't have any issues with this particular error. Looks like that took care of it. Okay, well, we'll move on then. Okay, so we are looking at agent 159. Oh, right. That takes care of that. So we're good there. Okay. Let's see. Hex tile. Nope, it didn't like that. Okay. God damn it. Um, hmm. I don't want to have to. I didn't really want to look up the the value in the hash array just to fill in the information here on this. I just want to remove that value from the hash array on this. This is unnecessary. Hmm. Let's see. Let me see if there's a way that if someone else has kind of tried to figure this part out here. Um, removing, remove a key, no value. It seems the concurrent dictionary only has a try remove method but no remove method. Why is this? I don't care about the value when I want to remove an entry by key. How can I do this? To remove the value and throw it away, as simple as that. But I don't understand why it's necessary to provide a value at all. Um, is a native method of concurrent dictionary, whereas like with other collections you don't have to explicitly implement. Let's see. The lack of remove and the existence of try moves because two different threads may attempt to remove a specific item from the collection at the same time, but for obvious reasons only one can do it. Try remove tries to remove the item, but if the item is not found, no exception will happen. Okay, I see what's going on here. Thank you for the answer there. I appreciate that. I mean, technically, um, I mean, if someone is trying to get the same exact information, like, hey, I'm going from this one location to another location, and another one's trying to say, hey, no, this isn't correct. You're gonna need to remove it. Then you have basically two threads at the same trying to access the same exact information at the same exact time. One is trying to remove it, one's trying to actually access it, kind of thing. So if um, if one removes it before the other, um, then that's all good. But I mean, if the other thread beats out on pulling the information out of it, then it doesn't really matter all that much. So um, you're just gonna have some issues trying to. It's gonna have some issues trying to get the information if the remove happens prior to it. If you have like well, okay, I have it set so that if the hash key or the hash value in this doesn't have a value to return, then it establishes a new path for it automatically. So, um, so I'm already kind of handling that particular scenario already. So, so it's just a matter of trying to, you know, safely remove the value from it. So, um, we just have a hash path here. So, um, hash, right, or hex path. So okay, we don't need to create a new object of it. We just need something to kind of put in there for the time being, just to say, hey, we got something back. It doesn't, but doesn't need to go anywhere. Um, we don't care about what is being returned by try remove. Okay, so that should handle this portion. Hex tile 59. So right. Um, Current dictionary does not have um, doesn't have an add. Let's see, concurrent dictionary. Let's see. What is going on here? Why do we have so many multiple variables here? What's this all about? Hmm. Hmm. This is interesting. SK2 is already set to that value. Okay. Let's see. What's going on here? Hmm. I'm trying to figure out why. What's going on here? Why do we have all these batteries? Don't really need them. Sorry, I'm um, seeing that I'm fairly new to C sharp as well, trying to figure out what these, update value factories are all about. So, what's the purpose of a factory when you just want to, um, change the key to the specific value that you want to add to it? What's the purpose of this? You know, Basically what this is doing is that it's adding one to this value each and every single time, and it's like, well, why even bother with this? Use I. to just place it there if you're just gonna go through all of this? Why need all of this? You know, if they wanna if they wanna do some kind of calculations or manipulations or changing of the value, then they can kind of do that outside of this. So what's the purpose of this? Why even bother? I mean, this is I mean, okay. I can understand it if you're wanting to um if you kind of want to change the like, you know, add value to, you know, the old value. Okay, if you know, if you're wanting to add one to the old value whenever you get some new information and all that, that's great. I mean, that can work. I understand, you know, that this could be helpful for someone that might want to, like, say, hey, we found another result for this one particular key. We're going to update the value contained within it, you know, by one. We're basically going to say, you know, like, say you're trying to do like a resource management or you're counting stock or something along those lines, okay, and you're finding the fact that you have the same kind of barcode for one of your products. So instead of a single product, you now have an extra one. So you're going to add an extra value onto this value. Understandable. I get that. Okay. Um, but sometimes you just want to straight replace. You know, you don't need to worry about these kind of calculations. Okay. You just want to take the value, you know, the key that you have and place in the value in that spot. That's it. That's all you need to do. Why have these factories in there? Why do you need these factories in this particular function? You know, I could totally understand the need for these if someone wants to work, you know, wants to have, you know, do some kind of function with them. But if you just want to do a straight replace, what's the purpose of it? You shouldn't need to. You shouldn't need it. And um, yeah, let me close out these. Um, and I don't want to do the getter add because, you know, what happens um, if the path has already been added? It's not going to overwrite um, the previous value there. Or at least it doesn't look like it's going to overwrite. Um, See, it looks like um, it looks to me like they will not overwrite the old value with the new value. Otherwise, it would always return the new value each and every single time. So let's see. Let me check this one out. Um, File set the key already exists. Okay, so this isn't going to overwrite either. Yeah. What's this all about? Key the value that is compared with comparison value and possibly replaced. Value that replaces the value of the element that has a specified key if the comparison result is equality. This is okay. I'm having a little bit of a problem with the assumptions that are being made for this particular concurrent dictionary um, functionality here. And you know, I could be completely wrong. I could be having kind of the wrong kind of mindset for it or something along those lines. Okay. Um, so you're trying to update, okay? Meaning, you know, you should have a key and a new value that you want to update with. How would you even know the old value in the dictionary? Why would you even want to know the old value in the dictionary? What's the purpose of this? I mean, if the new value is the same as the comparison value, then nothing gets changed. Okay, no big deal. Okay. If the key is you know, if the key is something that is already in the dictionary, then you place new value into that old value. Why do you care if it's the same? Why do you care? You know, why do you care if there's a comparison value here? What's the purpose of this? You don't need this in this particular case. What's going on here? This looks like it should be kind of handled internally or whatnot. You check to see whether or not new value is the same as comparison value. If it's the same, uh, And this isn't even correct either because comparison value here is a t value, not a t key. If the value with key was equal to comparison value, it was replaced with new value. What? So you're basically saying, hey, um, key, we want you to verify that you do indeed actually have this particular value in your dictionary before we can set the new value in it. Otherwise, nah, don't do an update. Why does it matter? Okay, so let's try this for example. Let's say we have two threads going on at the exact same time, right? Okay. And the new value, you have two threads going on at the exact same time, and you have they basically go, hey, you know, we have the same key and we generated the same new value for each of these. Okay, and both of them have the comparison value. Okay, this one goes in first. It goes in first on the pathing there to kind of change the value around, right? So this thread goes in, comparison value gets checked, um, and verifies that it does indeed, have um, the right kind of value inside there. So it replaces the new value, you know, with the comparison value. Okay, so now you have the key with the new value in that particular spot. So then you have the second thread coming in. Okay, you have the key, you have the old comparison value or the old value, and you have the new value. Now the new value is the same, so this is going to be false. So what's going to happen on the return along those lines? You know, the person gets back a true at one particular point in time saying, hey, this has been updated, and gets a false back on the second thread. What's going on there? How's the programmer going to handle that kind of situation? If they suddenly get a false back on their update, they're going to have to kind of figure out why they got a false back, right? Well, if they're getting multiple threads all at the same time, then, how are they going to handle that? Okay. This feels so unnecessary. There should be just an update. Here's the key. Here's the value. Was the key found? No. No update needed. False. Here's the key. Here's the new value. Key found. Replace old value with new value. Done. True. That's it. That's all you need. Why do we have this? What's the purpose of this? Uh, this should work. Why shouldn't that work? Oh, this is probably just the triad. Yeah, it's basically saying, hey, um, here's your first one there. Uh, you should add it in. Um, so you had the triad here, which is understandable. Okay, triad should definitely be like, hey, um, you're trying to add a value um, into the original spot. It already has a value in there, so you can't add in that same exact spot. Understandable. Um, why should you need to worry about one here? You should just need to do try update uno, and that's it. Why do you need the old data? Um, say what's the purpose of this? Mm, I don't know, man. It's just seems too much necessary for it, but that's me. That's my mentality right at the moment. Hey there, Pete. How you doing there, bud? Try update method update only when key value matches with old value. Oh yeah, I know. I'm getting that from this. My point is that why do you care about the old value in it? That's all I'm saying. Um, you know, why do you care what the old value is if you're just trying to update it into a new value? So that's all. Like you, I like simple variables. Yeah, it's this is this feels unnecessary. So, you know, what happens if you don't know what the old value is? How are you ever going to update this if you don't know what the old value is? You have to basically look in the dictionary for the old value just to say, hey, here's the old value. You're doing a if you don't know what the value is, you have to do a lookup in order to update. It's like, why? Why do you bother with this? Um, and what happens if a thread replaces it, replaced it with a different value prior as well? Like let's say you have, two kind of threads, okay, and you don't know what the value is on either one of them, okay, but they have two different update values, okay, and they're kind of coming in fairly quickly with each other. I mean, it could be along the lines of, say, like stock price values, okay, stocks change, you know, on, rapidly. So it goes in, it looks to see that, hey, um, uh, we check the values, we check to see what the value is currently in there. So, it pulls that value, or that, I'm not quite sure what the processor or the preprocessor is going to handle at that, during runtime. Okay. If I put something here that basically says get the key or get the value from the key, okay, inside here, is it going to handle this one particular method first every single time before it goes on to the next try update? Like, will it will the first thread handle this one altogether before it goes on to the next one? The second thread's try update, or will it handle the get values in both of these, filling in the values contained within them, and then it handles both of them one after another. How does the processor handle, how does the runtime handle that information? Okay. If it handles the get information inside the try update for both of the threads prior to doing the try update, then you have a potential of causing yourself an error here because one will update, but the other will not. So it's, I don't know, it's one of those, it feels like you're potentially causing yourself more hardship overall, try to do this information here. So now, technically, I could use like um, I could probably try to use the dictionaries version, of adding, of removing, um, although it doesn't have any updating from the looks of it. But I mean, I shouldn't necessarily need to. That's the thing. Hmm. Okay, well, this is just adding some extra um, this is just adding extra content on here or whatnot. Um, I was just adding some additional difficulties onto my code. So, um, let's see. Add or update. Um, don't need factory. Um, let's see. Mm, okay, I don't think that's what I'm looking for there. Um, let's see, I don't need, um, I need add or update. Don't need get or add. That's not what I need. Um, let's see. Both appealing and, if not fully understood, hideous. Yeah. Um, I need to explicitly lock access to it. While this is true in principle, there's more to it than meets the eye. As a general rule of thumb, protect the invariance of the data they are holding. In this case, the entries of the dictionary, more specifically the keys and values. Um, um, let's see. Let's see. Start by looking at how add or update operates internally. Following steps are performed repeatedly until one succeeds or an exception occurs. There's two cases to consider. Either an entry already exists or it does not. So, all true. Did value internally. Um, let's see. Did value factory. Hmm. Yeah, no worries, man. This video will be, here on Twitch, so you're welcome to kind of stop on by again, um, to see what I found. So, eventually I will try to get this up on my YouTube channel. I'm just behind and uh, been trying to force myself to get there, but I mean, uh, I have a lot of videos that are behind on that, so um, eventually this will reach my YouTube channel. That's the intention, but it'll probably be like, who knows, maybe months from now before this particular video goes up. Um, so, but at least Twitch is allowing me to kind of store information. So you have yourself a good night. Thanks for stopping on by, man. I appreciate it. Um, you take care. You have a good night. Catch you next time. If the entry does not exist, equivalent try add is attempted. If it succeeds, add or update is complete. Fails, that means another thread has concurrently created it. Concurrent thread loops then attempts to update the existing entry, ending up in the following case. If the entry does exist, the concurrent value of it is stored as old value. Then update value factory is invoked and the resulting value is stored as new value. For the key, the lock is required. This lock is not distinct for each key. That would be quite wasteful for large dictionaries. As with most dictionary implementations, a key belongs to a bucket and each bucket has its own lock. That ensures at least some concurrency when updating entries, as the dictionary is not completely locked but instead only contain Only certain ranges of the entries are locked depending on how the keys that are being handled simultaneously are distributed. Hold and lock the actual entry for the key is looked up again. Now the value of that entry is compared against old value. If the values do not match by virtue of quality compare default, that means that another thread has concurrently modified the entry. Therefore, this thread has to retry from the beginning. Note that it is important not to restart at step 2 or step 2a because in the meantime the entry could have been removed by another thread. Step 1 would be the right thing to attempt next. If the values do match, then the concurrent modification has happened and it is safe to replace the current value of the entry, again which still is old value, with new value. There's some optimizations about values that are atomic in assignment, but generally the logic is the same. The actual update is the entry's value is done holding lock, but only so to protect the internal state of the dictionary instance itself. The update value factory delegate is non-invoked while holding this lock. Since the whole procedure would be executed many times for the same key in the same adder updates call site, due to contention of multiple threads executing in parallel, the update value factory delegate could be invoked multiple times before resulting value is inserted or added into the dictionary. And you call add or update simultaneously on different threads. Add value factory may be called multiple times, but its key value pair may not be added to the dictionary for every call. For modifications or write operations to the dictionary, concurrent dictionary uses fine-grained locking to ensure thread safety. Read operations on the dictionary are performed in the lock-free manner. However, add value factory and update value factory delegates are called outside the locks to avoid the problems that can arise from executing unknown code under a lock. Let's see. Another thing to know is that checking two values for quality should be well defined. Yes, that is how concurrent dictionary decides if the value has changed. If you simply use default object equals for a reference type class, then only the exact same instance will call as being equal, which may or may not be what you want. If you want to use a value type as a value, then quality will be defined by value quality, but for custom types, you should probably still overwrite equals, and if only for performance reasons. An immutable data structure type object is simply put an entity whose state cannot be modified after it is created. There is no shared state that could be concurrently modified by multiple threads. That makes them predestined for use in multi-threaded situations and for concurrent access. Type, string, change the content of existing string instance. If say one string is appended to another, new string, right? case of add or update immutable values in the dictionary, that's super helpful. Doesn't matter how often update value factory is invoked before the return value is inserted or updated into the dictionary, because each call is side effect free with regards to the value itself. Okay. At the start of the dictionary does not contain an entry for key. Thread 1 calls our update, which will determine that there is no entry. After that, its quantum is used and is preempted, and another thread runs. Calls at our update, and it will determine that there is no entry, thus creating it. Then is preempted. So both of them will see that it's empty at the time, and we'll try to add a value into. What's going on here? when it comes to thread safes, or you know, if you're trying to add something in, you should lock the dictionary. So thread 2 should never even get to this particular add or update value. It should basically be saying, oh, hey, we have an add or update going, we already have an add or update going on right at this moment in time. We should, you're going to have to stop. But this is basically saying, hey, you're going to have to go on through and test for that particular key. Okay. Thread 1 resumes after both of them checked for the key, apparently, and will attempt to add the entry. That fails. Wait, what? Thread 1 resumes and will attempt to add the entry. That fails because meanwhile the entry is already present, added by thread 2. What? Why is this one failing and why was this added in? It should be the other way around. It should be thread 1 added the 1 value in there when the key wasn't found. And thread 2 should be the one that basically says, oh, hey, there's already a value contained in there. I'm going to have to go through the factory. Thus retry and go to an update entry logic case determines old value to be 1. I will then invoke the update value factor and keep the result as new value on the thread stack. Then it is preempted. So thread number 1, old value is 1. Thread number 1, new value is 3. Thread 3 calls outer update, sees the entry exists, invokes update factor. Now also succeeds in update the actual value. Current entry value is 3. Thread 1 resumes and continues. Resumes? What? And continues by acquiring the lock for the entry. It then checks the concurrent value again and observes that 3 does not equal to 1. Thus, the concurrent modification has happened and needs to retry from the beginning. Why is thread 1 being the thread that has to retry each and every single time at this point? What's going on here? Upon retry, the thread again determines that the entry exists with the value 3 and thus calls update value factory again, now getting 5 as a new value. We can introduce more and other threads continuously interrupting each other, and especially thread number 1 and its quest to update the value, but the point should be clear by now. Assuming no other thread intervenes or interrupts, the current value is finally updated to 5 by thread 1. Thread 1 will never go anywhere. If you have threads that will continuously update the value over and over and over again, then thread 1 um, is never going to finish. You have a what's the word that I'm looking for? Um, um, multi-threading locks. Um, there's a specific word that I'm looking for, and unfortunately it's escaping me right at this point in time. Um, um, let's see. Um, yeah, starvation. That's basically what's happening to thread 1 in this particular case. Thread 1 will receive starvation because you're going to have other threads that are updating the value, and thread 1 will never go anywhere. Thread 1 is dealing with starvation in this particular case. You're basically going to have a lock on thread 1 that will never see the light of day. It will never finish. It will never progress because the other threads are taking up the uh, they're taking care of each of themselves without any additional problems. You're causing starvation in this particular case. I'm not really liking that all that much. I don't like the idea that um, that I could potentially be having a starvation effect on one of my threads. That's okay. Um, let me try to refer. Let me try to explain this a little bit. So let's say we're trying to do the add update, on um, for pathing. Okay, we're trying to establish a path for one of our agents. We um, we put the agent down, so he's gonna try to find the right path. But then we start adding, like like we have a spawn location, and we just have a single spawn location. So we just keep on putting, you know, agent upon agent upon agent upon agent on there. Okay, and we keep on doing the add update each and every single time to try to find the path for each of these agents. Well, each of these agents has the potential of, going with their own unique threads. So, like the very first agent could basically get stuck at that, um, at that spawn point because the other agents spawn in and take up the add update. Now, obviously, you know, I'm just giving hy hypothetical here because the processing of all of this should be fairly quick. Okay, so you know the the spawns that I'm having for each of these agents um, shouldn't be, you know, that quick. Okay, it should take enough time for, one agent to find its path to move on to another location. Okay, but let's just say that all the agents converge on one particular node. Okay, and um, they like mine out a particular resource, and then they're all pretty much stuck there because their threads of like they add an update, they're going to be trying to find a new path to kind of take or find or whatnot, and you have the potential of a lot of them getting starvation in this particular case. Because if all three of these threads were being called at the same time for add and update, then that means that thread one is can't go anywhere. Thread two can't go anywhere. Thread two is going to have the exact same pattern as thread one, right? So that means thread three is going to come in and say, okay, now I get to update everything, to the current entry value, and then it will proceed on to, see, does it have, which thread takes the priority? Is it thread one or thread two in this particular case? Does it go back to thread one and basically does this whole endeavor, or does it get locked once again, saying, hey, um, thread two still needs access. So is it, um, are we dealing with uh, a stack situation and not a queue, meaning that Um, the first thread gets put on the stack, the second thread gets put on the stack, the third thread gets put on the stack. No other thread happens, so we pop thread number 3 off the stack. Um, you know, handles everything on the thread 3. Um, then we go back into stack. We obviously thread number 1 isn't on top of the stack anymore. It's thread 2, so we handle thread 2, and then we eventually get down to thread 1. Well, what happens when thread 4 and 5 comes along? Are they going to be put on the stack, and once again thread 1 basically sits there? It's you're basically talking starvation in this particular case, and that's not great. You're basically hanging up a one particular thread on that. Am I wrong? Am I is this not the right observation on this? You know, I mean, if you've kind of seen this before, if like if you know, what this particular gentleman is kind of talking about with the concurrent dictionary and so on and so forth, and um, I was kind of dealt with this particular issue in the past. Am am I wrong in making this assumption that you have the potential of having starvation for thread 1? I don't know. It definitely sounds that way based off of what this particular gentleman is kind of talking about. Hmm. One could attempt to lock the logic inside update value factory against multiple concurrent invocations. The result is almost expected by now. Again, the concurrent case produces a wrong result as more invocations to rinse and repeat because multiple threads have attempted to update the value concurrently and invoked for each retry. Why does this not work? Because the lock inside update value factory cannot prevent it from running multiple times for the same add or update call. Oh my god. It can protect some sort of invariant inside the mutable data instance because it prevents executing 2 or more update value factory at the same time, but it cannot help otherwise. I... So in other words, if you basically basically from what I understand, if even if you try to lock update value factory from executing, you essentially cannot. It will still execute the values contained within it. see. Um, let's see. Hmm, let's see. Make things even more interesting, using a concurrent dictionary still works nicely with mutable values if you ever only ever add and retrieve entries. Um, and never update them. Um, it is of course rather dangerous. A future maintainer might instantly update values in the dictionary and things start to break. And to make things even more unfortunate, this introduced error might not even surface immediately because it depends on actual concurrent usage. Wow. Considering all the effort and correctness reasoning required for immutable values and preventing brittle code for future maintenance, even with immutable values, uh, it might worth considering using a plain dictionary with explicit locking instead. Then go with that until measurement and profiling have proven this to be a bottleneck for your scenario. In either case, there are potential issues with performance since multiple invocations of update value factory and add value factory can and will happen. Whether that is an issue for your scenario depends on how expensive these extra invocations are and how often they generally will happen. The frequency is governed by the level of concurrency and contention that may arise from it. There's no universal answer. You have to measure and profile common use cases to find out potential problems. Some potential problems can still be addressed using value wrapped and lazy. As not shown above, this does not help with the issues of immutable data, but can reduce and prevent extra expensive calls. However, wrapping a value into lazy will add memory costs. In the long run, each lazy instance requires 24 bytes on a 64-byte architecture. Uses some more bytes until the held value is created for the value factory delegate and some internal state, but that will subject to GC when the value has been requested. If you have literally millions of values in the dictionary, that might add up, but again, profile and measure before drawing conclusions here. As so often in software development, there seldom is a universal right choice, and such is the case here as well. This article is thus attempted to outline some of the issues involved and give some guidance and hints. As always, you make up or YMMV, which I'm not quite sure what that stands for. Let's see. Okay. So this is worrisome. basically this person just explained that there could potentially be starvation on with concurrent dictionary, even though it's supposed to be thread safe. Yeah, I don't I don't know what's going on here. Why um if this indeed is the order of progress to be handling the threads on add or update, you know, that thread one does not get processed, you know, first out of all this, you know, it doesn't lock thread 2 or thread 3 before thread 1 is done, then I don't know. I don't know. I don't know why they do that. You're basically causing starvation for thread 1 in this particular case. If this is indeed what happens, you know, I'm taking this person's um, information that they're saying here at face value. Okay, I'm if this is indeed what happens, okay, then this is not ideal. Okay, I don't want to have an agent be locked in place, like okay. Here's a potential scenario that could happen in my game. So let's say, you have all these ad updates being done all at the same time, kind of thing. Okay. Now, each of these agents are going to be on their own tile set, but I don't know whether or not the ad update um, will be able to kind of distinguish whether or not um, uh, the the tile that the agent is located on is going to be separate from another tile another agent is located on. Okay, so their ad updates are going to affect, you know, that particular tile. Okay, I'm not sure. Okay, that that has the potential of that might be a thing. That might be something that is kind of going on right at the moment. Okay. Um, if we're doing add update for one tile and add update on the other tile, is it going to lock one of those add updates even though it's never going to affect what's kind of contained within that particular tile? Is it going to handle this add update over here for this one tile and then unlocks to handle this one over there? You know, what happens in that particular regard? Okay. Um, I don't know. And that's kind of worrisome to me because if say this particular agent here has an add update and this particular agent has an add update, agent number one gets locked so that agent number two can handle what they need to do. What happens when another agent comes along with an add update? Does this guy remain locked? You know, third agent gets handled, fourth agent gets handled, fifth agent gets handled, sixth, seventh, eighth. What happens to agent number one? Are they going to just sit there waiting for to be unlocked to allow for its process to be handled while everybody else is being processed? Not exactly ideal. You have a starvation effect over here for your one for my one agent. That's concerning to me. That's really concerning. And I don't know. Um, I don't know if I want to go this route now. God damn it, man. I keep on wanting to get into the D-Star coding, and I keep on finding problems like this. For those of you that have been kind of sticking with me for the past couple of weeks, you're probably going, "Come on, Jim, get into the D-Star already. You've already talked about it for a couple of weeks." I know, I get it, I understand, but you know, um, if if this doesn't work, if these nodes don't work the way I want it to work, then my D-Star is going to fail, and I don't want it to fail. I need it to work as well as it needs to work, so that my agents can, you know, properly move about the level. So, so am I gonna have to just kind of go back to dictionary? Hash table, um, hash table is thread safe, but, um, it doesn't have the, what kind of functions, if I remember correctly. Or um, it was the boxing and unboxing that was the issue with the hash table. I was, um, you know, um, the data retrieval is slower because of the boxing and unboxing, but it's thread safe. But I would have to keep everything kind of contained within objects to be used within the hash table, which doesn't really work for me per se because I'm going to be using different, I'm going to have set values in it. Um, so the problem is that if if we have the potential for starvation happening with our concurrent dictionary, then I'm a little concerned about it. Um, Acceptable to starvation. Um, uh, concurrent queries. Is here roadblock because each query is from a separate context for that to work. The test is well. Waiting for the query, threads are seen, it is returned to the thread pool to be reused. This helps with thread pool starvation in the case when the process must service many requests. And this doesn't really answer the problem with the concurrent. Let's see. Cache request decide the values returned from the other two. Spends time makes me wonder if you can say this class is even thread safe. Concurrent dictionary has the same behavior. I tested it and same thing happened. Um, Lazy task is tricky. If the task fails, the lazy value is still created as far as it's concerned. This exception is only thrown when the task is awaited. Await the task. There are different solutions available. Most famous of which is probably Lazy Cache. It's a great library. Another one you'll find useful is Fusion Cache, which I recently released. It has the same exact feature, though implemented differently and much more. Feature you're looking for is described here, and you can use it like this. You may also find some of the other features interesting: failsafe, advanced timeouts, factory completion, and support of optional distributed second level. Chance, please let me know what you think. Shameless plug. uh, and it's expensive to do that. According to word multiple threads like that, you need to lock. But using a C# lock statement is an asynchronous code lead to thread pool starvation. Fortunately, Semaphore Slim provides a way to do async locking, so it becomes a matter of creating a guarded memory cache that reps an underlying iMemory cache. And same Semaphore and entire cache plane. Let's see. This is right down below email. Um, Semaphore. Semaphore thread A removes Semaphore from the dictionary. Thread C creates a new Semaphore for specific key. Result B and C threads are currently invoking the factory for a specific key. Doing it correctly is quite tricky. Take a look at this question if you want. Um, let's see. Um, Similar native memory cache prevents concurrent invocations of displayed asynchronous lambda under no conditions. The intention is to enhance the efficiency of caching mechanism under heavy usage. Still, the possibility of concurrency to occur, so this is not a substitute for thread-safe synchronization if needed. Simplification also injects faulty tasks from cache so that failure synchronous operations are sequentially retried. One, Microsoft cannot do everything. They're constantly getting requests to add stuff, fix stuff, improve stuff, and invent stuff. Yeah, pretty much. Let's see. It's also thread safe when using thread. Invalidates cache. Can never be slower because it creates lazy instances that never will be executed and uses lazy in full thread safe mode. Update with new benchmark hires better. I suppose a new thread comes with the same key while the first one awaits to populate. But for the same key will be executed necessarily twice. With count one, solution would be to set a lock, and then you can get around the issue of waiting and set a lock. All other methods make cache thread safe. Let's see. Um, hmm. Okay. Let's see. Memory cache to. I mean, this is getting into stuff that I don't really need to look at too much, but at the same time, it might provide some amount of context because it it sounds as though um, concurrent dictionaries, you know, like I guess you might say cousins, you know, to what I'm seeing here. So it's not exactly the same, but it's similar. So yeah, I'm not sure. Okay, we're getting kind of off track here. Um, yeah, PDF here. Let's see. Okay. Uh, okay. I think at this point in time, I'm probably gonna need to just kind of um, crap. I was kind of hoping that I wouldn't necessarily need to worry too much about dealing with, locking and unlocking threads to try to handle all this. But I might need to do that, which can be problematic because now I'm gonna have to try to deal with, you know, um, race conditions, starvation, and the like on my end, you know. Uh, if concurrent dictionary has the problem of creating starvation within itself, then it's not as safe as what I want it to be. And hash table isn't that useful in terms of the boxing and unboxing. I don't really want to deal with that either. So, I'm gonna have to just switch it over to dictionary and then try to wrap, uh, you know, uh, thread locks around them. Let's see. Um, See, unlike the add method, this method doesn't throw an exception if the element with a given key exists in the dictionary. Unlike dictionary indexer, try add doesn't override the element. The element with a given key exists in the dictionary. If the key already exists, try add does nothing and returns false. So it doesn't even update. There is no update in the dictionary. Hmm. So this might, if I'm gonna have to go back to the dictionary to try to take care of all this, then obviously I'm adding additional code into my program to try to handle for this, to try to handle for thread being thread safe and like. I mean, I do want to try to get this into a point where um, we're accessing the values, we're changing the values, we're modifying the values based off of what they're doing on that particular node. And obviously, we don't want to cause any like major issues or something along those lines. Okay, um, like for example, say a path was already created. Okay, so the attempt to add to that old key is going to fail because that that key has already been established. Okay, it's going to return with a false. Okay, so therefore, um, I want to check for the key first before I do any kind of um, adding. So, um, I'm going to want it to do um, contains key first to see whether or not it's there. And if it's there, I can't really add it. Um, well, I mean, I could do the try key as well. That's gonna um, this will add it if it's not there. If not, it returns false. Okay. Um, and if it is there, then obviously um, the attempted add might be wanting to put in a new value in there. In other words, a new path in my regards. So so I'm gonna have to remove the value. Um, let's see. Does the key become Does the key become zeroed out as well? Does it remove the key as well? Let me see on that. Uh, let's see. Um, okay, this particular remove does returns the value out of it, which I don't really need for mine. There's no real update, so I would have to basically um, so if the path was already established for that particular key, then I would need to check to see if the key exists. If it does exist, I have to remove it and then add it in. But I'm gonna have to change this. I'm gonna have to modify this and for just dictionaries. So, okay, well, so generic dictionary. There we go. Okay. Um, let's see. Remove hash key. Okay, so it has to. Um, Actually, hold on. I'm gonna make a little note here. Um, current dictionary was um, uh, I read that concurrent dictionary could have the potential of starvation for its threads. I do not want any of my agents walking around in lot in place because one thread can't finish its work. So we are switching back to dictionary and we'll attempt to make everything thread safe through my own efforts. Okay. So let me put this back for now. Let's see. See, clear. There, right. It's perfectly fine. Same as before. So we don't need to worry about that. Okay, so here's where we're going to need to kind of work on this a little bit. Um, so we're going to need to do, I have to kind of do like an update path here. So um, okay, so hmm, I'm not mistaken, I can just kind of do a um, yeah, I can just kind of say, hey, this is the value contained within that particular key, and that's fine. Um, so um, so getting the value from that is perfectly fine as a get value. So um, so um, thankfully it's all if it's a single value here. Or it's a single check. So, um, but I can just kind of use this one here to kind of do the check for us a little bit. Um, so so if uh, not contains key hash key, then we can add else um, we want to we're just going to update it. So I mean, we're going to have to kind of change what's contained within there. So map pathing. Actually, let's go ahead and do just remove path with hash key, and then we'll do um, remove path doesn't work. Oh, here. What I was planning on doing was kind of doing this again, because um, well, actually, hold on. No, we can do something a little differently here. There's no need to call this function over again. We just need to, if the key is found, then we just want to remove the path from it, and then we add back in. If the hash key isn't found, then we don't need to remove it because it's not there. But if it is there, we remove the key and the path and re-add it back in, because most likely this will be an updated version, maybe. But I mean, the we're already establishing. Um, okay, so if I handle my code correctly here, okay, just letting you know here, okay, if we're handling the code correctly, okay, then we're already establishing a path. Um, you know, we're if no hash key has been found, in other portions of code, okay, then we know that there hasn't been a path that has been established. Um, so we use the D star, get the path, and then we can then add that path into our tile here. Okay. Um, if because of it's a D star and the fact that we have the potential for having updates to the landscape or whatnot, a change in the path might be necessary. Okay. Um, new, our initial route might be blocked. Okay. Uh, we might be having a hard time trying to find the route to where we kind of need to go to. So therefore, our path may need to update at some particular point in time. So, like the flag of war uh, gets kind of knocked out as the human player continues to expand outside of their control. Um, continues to expand the human base. Um, then the fog of war goes away, and the pathing that was originally set might need to change or might need to be adjusted. Okay, so the the original destination from where they're currently standing at may need to be removed and updated. So, and I don't really care um, that this is happening almost on a constant basis here. Okay, because um, the uh, this shouldn't take that long to process overall. Okay, so um, let's see. Actually, we want to do pathing. There we go. So we're checking map pathing to see if it actually has that particular key in there. If it does, remove it and update it with a new path. That's basically what's going on here. Now, um, here's where things get a little problematic, because what happens when you have multiple um, uh, multiple threads trying to handle the exact same thing all at the same time. Okay, trying to read, remove, so on and so forth to try to get all this information. Well, um, that's where I'm going to have to kind of come in and just basically say, um, you know, hey, lock all threads till this is done, and then unlock all threads, or something along those lines. Okay. Um, Obviously I'm not there yet. Okay, but I need to handle this one thread for with removing everything, or removing this particular hash from the dictionary so that I can add in the new hex path into it before I can unlock everything for them to read that, hey, we have um, we have someone trying to say, hey, I need the path for this particular hash key. Okay, so um, now I'm probably going to need to do something here as well for lock and unlock as well. Because if I'm just going to do a straight remove here, then or if I need to kind of do this outside of my add path for some reason, then I'm going to need to do a lock and unlock here as well. Um, I'm going to need to um, I'm getting the path here, so I need to um, have a lock and unlock here. Make sure that that's handled. Um, this is fine. That doesn't need a lock or unlock. Um, there shouldn't be multiple threads happening for the clear. There shouldn't be like an add path or a read path or get path or anything along those lines for this. But just in case, I should probably go ahead and do a lock and unlock here as well. Um, so we should be good for the most part. So that's the initial thought lines about it all. So um, let's see. Um, Probably gonna need like a lock here. Um, let's see. I don't think I'm gonna be needing this to be locked and unlocked because each agent is gonna have their own hex path, their own copy of a hex path. So they're not going to be reading from the same object. At least that's the intention. Okay. Um, they should be having their own straight path for themselves. So, you know, one agent is going to be able to read another agent's path. So, at least that's the intention. Um, Whether or not that actually works out is, well, we'll see. um, the adding of the path could potentially be a problem. That's why I'm kind of um, that's why I'm uh, thinking of locking or unlocking. Um, but again, this might not necessarily be that big of a deal as well because once again we're dealing with um, we're talking about one particular agent with their one particular hex path. So that might not need a lock or unlock potentially. Um, I don't foresee it needing it, so at least not completely. Uh, but you never know. I might get to a point where that becomes necessary. So um, yeah, okay. We're gonna have some issues here a little bit. Okay, so 12 errors, huh? Okay. So once again, still dealing with the max tiles there. Still dealing with agents 125. Next tile there. Generate hash key. Seems like a lot of these are the non-static field errors. So, okay, we'll deal with that a little bit later. I'll I'll worry about these other errors that I'm dealing with here first. So, Okay, determine destination. It's saying, hey, you need to give me some values here, so um, let's see. So what I'm gonna do is um, hmm, let's see. We'll do float x is equal to destination x, and then we have float y is equal to destination y, and then we'll just put them right back in. There we go. Just to get past the one error there. So, okay. Game manager 140, 141. Right, it's not Boolean, it's bool. Okay. Um, Game manager 142. Path follows inaccessible due to its protection level. Okay, so path to follow is private. It is. Hmm. Um, let's see, am I using it multiple times? No, I'm not. Okay, so I don't necessarily need to worry about that too much. So I think what I'm going to need to do is let's call a function to check to see whether or not path to follow is actually null. So um, so so that we can kind of see it outside of it. Obviously, you know, them checking whether or not it's null inside here doesn't really matter because it's within the agent itself. But um, but I should probably have like something that checks for outside. So um, so let's see, testing path, determine destination. Let's put it right here. So we're doing a public bool um, is path null. Um, if path to follow is null, then return true, else return false. Okay, so we're gonna take that over here, um, and that should work. Okay, let's see. Now we have game manager at 163 having an issue. Let's see. Does not contain a definition for set destination. Mm-hmm. Let's see. Mhm. Set destination appears. Let's see, wait a second. All right. Um, mm, we want to have to determine the destination, and then we set the value of the destination. Um, so we should have something here. Public void. Set destination. Um, don't need to worry about um, having an outbound. We just want to set our agent's destination, which is destination. um, let's see, let's go ahead and rename it there so we don't have any confusion along those lines. So, um, so here we determine what, where our human agent is going to be going to. Are they going to be walking to a resource? Are they going to be walking to a spot to um, construct a barrier? Are they going home? These are all possible destinations. And then we basically say, hey, this is where this guy's trying to go to. So, once they get to that destination, then obviously um, we can like nullify the destination so that we can figure out, um, where the agent wants to go to again. Or they found, maybe their path isn't correct, like they get stopped by their path, so they need to redetermine their destination or something along those lines. We'll see. Um, but that should work for that now. So, oh, hello there, stream. Thanks for cutting out on me again at 5:45. I don't know why it keeps on doing that. Always weird when it does that. Apologies for the cutoff there, folks. Like I said, I don't know why my internet cuts out like that, but okay. Let's see. We have agent CS. Um, Use of possibly unassigned field X and Y. Okay. There, you happy? Nope, doesn't like that. Doesn't like that either. It doesn't like these. It's like, sorry, this isn't valid. It's like, uh, it's like, why? Uh, Vector 2 has to have a value to it. Vector 2 has to have a value to it. It's not null. You're assigning a value to this. What? What? Why? Yeah, let me show you. Okay. Um, you know, vector 2 null. Um, let's see. Um, vector 3 is a struct. You need to convert to nullable. I'm not converting it to a nullable. Um, uh, so I'm not using um, I'm not using a nullable vector 2 or nullable vector 3 or anything along those lines. Okay. So it has to have a value to it. It's not nullable. So therefore it has a value. So why is it giving me this error for it? God damn it. Keep on wanting to get into the D star and I keep on getting these other um, these other problems and I can't get past them. It's like, why? What's going on here? Um, okay, apparently agent pathing isn't two values. Right, we just have the one there, but that might have changed. Let's see. Right, we want destination next tile, um, so we have our destination and we have our factor 2 um, next tile node on that so that we can walk to that particular location. So let's see. Get past next tile. Hmm. Okay, well, we want this to be next tile node. Yeah, I'm gonna need to kind of fix that anyway. But let's see. Yeah, this doesn't really care um, about the destination values contained within it, so we should be fine with this the way it is. You know, using next tile node for the value in that, so we should be good. So okay. Tile key. See, 37. Hmm. This was from the board manager. Hmm. Let's see. Sure. Double. Um, hmm. Okay, so I just need system.tuple there then to handle that. So tuple, did that work? Let's see, in static, huh? Okay. Let's see. Will it understand create is its own under tuple? Maybe? We'll see. Um, yeah, looks like we're good there. Okay. Well, I gotta close on down there, folks. Um, I don't I don't understand these right at this moment in time. Um, I'll go ahead and clear out this next week. Um, then I'll have to figure out how I can access max tiles from board manager. Um, and then we'll have to figure out what's going on there. Um, so we'll have to figure that out next week. But I've been causing myself a lot of hardship with this, but um, and I'm probably going to cause myself even more based off the fact that apparently I can't use concurrent dictionary anymore, or I'm gonna cause myself heartache with that. And I'm probably still gonna cause myself some heartache by just using dictionary, but uh, it's no. Yeah, I was trying to avoid a lot of headache and hardship, but um, there it there appears that uh, there's no easy solutions to this. Which I mean, let's face it. When it comes to threads, it's never easy. Okay, anyone that thinks otherwise is, in my particular opinion, fooling themselves because you know when it comes to threads, you have to be careful with every single um, thread that you create and how you handle it. If not, you're you know potentially causing yourself um, some incorrect data, some race conditions, some starvations, all those, some deadlocks. I mean, these are all um, these are all problems that could really hurt um, the information that you might be wanting to send somewhere. So, like if a thread that you need to have, perfect sending data to like like to an application or something like that. You're trying to get like, you know, uh, up-to-date information, like, every second, you have information that is always going to be, you know, you need to get that information and you send it. Get, send, get, send, get, send. Okay. Um, and if you're not careful along those lines, then, if that particular thread gets locked for whatever reason, okay, and it's no longer sending information, then whoever's receiving that said information, say like, you're trying to study the stock market, and all the information there suddenly locks up. You don't have um, any data being processed, isn't shown to the user at all. Then they're going to be making judgments based off of information that's no longer up to date. And obviously, they could have a potential problem with that. So, you know, they could be like the stock market shoots up, but they're still seeing low value. So they try to pay, they try to purchase new stock thinking that it's at a lower price, but in fact, it's actually at a higher price. And now, you know, the amount of money that they're spending, or they basically say, hey, I want a couple thousand stocks or something like that, and instead of spending, $1,000, they now suddenly spend $2,000 or something along those lines. You see what I'm saying? So you want to make sure that your threads are perfect when it comes to along those lines. So um, now, obviously, for a game, you're not dealing with that much. You're not dealing with anything that is super important for the most part. Okay. Um, obviously it's important to the player, but it's not something that can make or break someone's fortune or something like that. Okay. Um, but at the very end, it's you don't necessarily want I don't want my agents being stuck out on the field, absolutely going absolutely nowhere because of one particular deadlock. So we'll see. We'll see what happens. It's a lot to do. We'll see when we get there. But that's where we're going to go ahead and call it for tonight there, folks. Um, once we get all this done, once we get all these errors fixed and out of the way, then I can move on to um, actually establishing the pathing. But obviously, I need this working. I need this working. So um, we're just gonna have to wait on that. So as a reminder, if you're interested in the stream team that I have available down below on my Twitch about page, go ahead and check it out. I have a link to the Google document that talks all about the team. So if that's something that interests you, fill out the application and submit it. I'll review it and give you an answer one way or another. Um, we're looking for streamers and non-streamers alike. So basically anyone that, um, uh, you know, anyone that can help out on the team is welcome if you're willing to help out in the team. Okay, you have to, you know, um, you know, we don't necessarily want people in the team that is all about themselves. They only care about themselves and no one else. Not exactly the most ideal candidate. Um, you know, obviously, if you're a streamer, then you do want to have some kind of improvements, okay? But you know, um, but we're kind of building a community, and everybody is going to be needing to help each other out for that kind of a community. So if you're just there for yourself and don't care about anyone else, then probably not the best team for you, okay? Um, if we're going to help you, you're going to need to help us. So that's how that's what being a team is all about. Okay. um, those of you that feel like I'm the only one that's important, um, not a great fit for the team. So, um, but um, if you don't feel that way, then submit your application. Okay. So I would love to see it. Um, but that's down below on my Twitch page, the application link. I also have links to my YouTube channel down below. Um, So you can go to my YouTube channel and check out all the videos that I've put up there. All these streams and videos are there for you to check out past streams. Um, I don't do any kind of editing, so it's all pretty much there for the most part. Um, so go ahead and check that out if you like. Leave a comment, leave a like, subscribe. It all helps out in the end. So um, let's see. I also have links to my Discord, my Patreon, and my Twitter account down below on my Twitch about page, as well as in the description of my YouTube videos. So feel free to check those out if you like. Um, you know, um, yeah. If there's ever like an update that I need to do, Discord or Twitter is typically places that I go to make those announcements. So, um, but that's where we're gonna go and call it. Um, I have a schedule of everything I do on this channel down below on my Twitch about page. So the these coding streams that I do, the Finish What I Start series on Mondays, which is tomorrow, and all the game streams that I do, that's all shown down below. So if you're not quite sure what I'm doing on a particular day, you can see that down below on my schedule. Stop on by during that window of time from 2 to 6 p.m. PST. Say hi in the chat if you want, or don't. It's perfectly fine if you just want to lurk. Either way is fine. But that's where we're going to go and call it for the night. So, Pete, thank you for stopping on by. I appreciate it. Um, uh, Hopefully, I'll see you again next time, whether it's next week or tomorrow, as you stated. Um, I also want to give a shout out to Wild Dog Alpha for the follow. He made a follow while I was offline, so I want to thank him for that follow. So I appreciate it. So hopefully I'll see you around, but that's where we're going to end it. So thank you very much for watching. I appreciate it. Hopefully I catch you next time. But until then, take care. Have a good night. Stay healthy, stay safe, and I'll catch you strangers next time.